In this video I introduce the software tools that are needed for the machine and assembly languages project. That is the Assembler and the CPU Emulator. These tools are supplied for the book, The Elements of Computing Systems, on the None2Tetris homepage. Here is my directory with the None2Tetris software tools. This time we will need the assembler, so I open that one. And the CPU emulator. I also opened an assembly program in a text editor. This is our small program to add numbers, in this case from 1 to 10. You know this program, we have it in the book and also in the video lecture. So let's look at the two tools we have. So the assembler is a translator. It translates assembly programs to machine language for us. Well, I open a source file and load it. Okay, so this is what you can see. We have the source file. Hopefully in the other side we will see the machine code. Okay, you see that this is the same source file, actually exactly. You can translate the entire program, or you can translate from instruction to instruction, so that's what I will do now. Well, first lines were comments, and then here we start to translate. Okay, so for example, the first instruction was an A instruction, putting the address of the memory denoted by I into the A register. Okay, and this is the machine language instruction for that. You can already see that I will get address 16. Okay, and so on. Okay, so we can translate line by line. You can also see that, for example, for this pseudo command we do not have any machine code, and then we have the code for the rest. Okay, and I get the message that the file compilation succeeded. Okay, so this assembler provides us a tool to check that the program syntax is correct. Okay, so just to see what happens with a program with an error. So for example, here I write m equal to 5 into my assembly code, right? We all know that this is not a valid instruction. Okay, I save it and open the source file again. Okay, here we see that we have this m equal to 5 again. So let's see what happens. Again, we translate the code from line to line. The first one is translated successfully, but then, so here we get an error message, m equal to 5 is not a valid instruction in our assembly language. Okay, so that's about the assembler. It has some other functions. You can, if you have a comparison file which you have for the problems for the home assignment, you can actually compare the result of your code and this comparison file you received. Of course, the assembler doesn't show whether your program is doing the right thing or not. Okay, so to see what the program is actually doing, we have to take the CPU emulator. So looking at the CPU emulator, let's see what we see in this screen. Here we will load our program into the ROM. Here we can see the memory. Here we will have the screen and also the keyboard. Okay, so if you press a key on your keyboard, then the key appears actually here. Here we have our arithmetic unit, the D register, the A register or the content of the virtual M register, and then finally the output of the ALU. We can edit actually the RAM, so we can type in values if we want. We can also clear it, which may be good if you have to run a program several times. Okay, it may be important for you to set the view to screen, especially when we work with programs that actually write the screen. We load our program. You can load in assembly or in Hack Machine. I will load it in assembly, and actually I corrected the mistake I made. So here we have the correct m equal to 1. So we load the ROM, and here you can see more or less your assembly program. Okay, so please note the differences. Here we do not have the symbols anymore. Right, instead of I we have 16, which is the address of variable I. The same way for sum we have 17. We do not have the pseudo command for loop and end anymore. For loop and end we have the address of the instruction where the jump has to go. Okay, so let's see what happens. Again, we run this program step by step. Okay, since it's pretty slow. If you would like to run your program faster, and you will need that to check the project that writes the screen, then instead of program flow, you can select no animation, and you can set the slow fast scale as actually for the hardware simulator. Yeah, but now we leave the program flow. So let's see, at 16 we see that we have 16 in the A register, m equal to 1. Well, we see that we have the ALU output 1, and also we see that 1 appeared in our memory at address 16. Okay, then we load 0 to M, and start to add the content of register 16 to the content of register 17. Okay, here we compare whether we are at the end of our loop. D minus A, it's minus 9. It means that we do not have to jump to the end of the program yet, but we actually have to perform the addition. Right, so now we have 1 also in register 17, etc, etc. With this I close this short demonstration.